Okay, so I accidentally forgot to record some U sub problems, but we're going to keep doing U sub problems and just keep going through these. Let's go on. We'll do more practice throughout the week. No, we want to review for the final. I think that means we'll need to put a U sub on the final test. We'll see. We'll see. Okay, the integral of ln of x cubed over x. Actually, is on the outside. Ln of x is the thing that's going to be cubed. Okay. So for u substitution, you let u be some piece of your problem. We're going to let u equal ln of x. Sometimes you have to try different values for u until you get one that works. But I know that this works. Get the derivative and solve for dx. And you substitute your value for u. You also substitute in your dx, which is x times du. And then we can see if the problem's easier to integrate after that. Integral of u cubed over x times dx, which is x du. So the x is reduced to 1. And it's the integral of u cubed du. Okay, we add 1 to the power and then divide by that number. Last step is put u back into your problem. So ln of x to the 4th over 4, or 1/4. ln. Absolute value. Wait. No, just ln. Okay, just what we started with. Power 4. Let's see. Okay, so we'll do one more where we do u sub, but especially since I wasn't recording earlier. But then we're going to try a problem that has u's in it, so we can't choose u as our symbol. We just pick a different symbol. Okay, this one is x over 1 plus e to the x. E to the x over 1 plus e to the x. I let u equal 1 plus e to the x. So again, sometimes it, as just a hint from someone who's done a lot of these, give it a try to let u be equal to whatever's in your denominator, whatever's under a square root, whatever might be up in a power, just a piece that's a little messy looking. This piece. Derivative would be e to the x. So dx is equal to du over e to the x. And then you put in our u and you put in our dx, and probably you can take the integral after that. Find the integral. Okay. U is that denominator, dx is right here, it's du over e to the x. Okay, so it's ln absolute value of u plus c. Ln absolute value of 1 plus e to the x plus c. Here, over to that integral, and then put in your value for u. Cool. So we're going to try having there it is. Okay. The integral of u times 3u squared minus 1, the quantity squared. Sorry. U times 3u squared minus 1 squared du. So same idea as u substitution, we just don't want to use the symbol u. So I picked, let's pick t. So let t equal 3u squared minus 1. Take the derivative, dt du, derivative of t with respect to u. So 6u. Solve for du. Multiply this by du, both sides by du, divide both sides by 6u, and then replace du and replace that, do that substitution you want to do. So there's u times t squared. And then du is dt over 6u. So u is reduced to 1. U over u is 1. Integral of t squared dt is going to be t cubed over 3 plus c. And then t is 3u minus 1. So I hope it's clear. You're doing a substitution. Sometimes it won't be so easy as I've been doing it. You might have to try substituting like another piece of your problem and just do some scratch work. Bear me with time. And got 10 minutes. And this was the big goal. It was to have you guys see U subs before you go to Calc 2. So are there any questions or concerns? I'm just going to keep doing more practice until we run out of time. Okay, it's got I want to change the problem, but then I don't know if it will work if I make that change. Okay, this one looks kind of funny, but it still is a good practice problem. It's an integral of 18x minus 15. Multiplied with 3x squared minus 5x plus 1. That piece is squared, and then dx. Okay, let's do like scratch work. Let's say that you try letting u equal 18x minus 15. Let's just give it a try. U over dx would be 18. So multiply by dx and divide both sides by 18 to get du over 18 equal to dx. So if I do it this way, I kind of get stuck. I would have an integral of u times 3x squared minus 5x plus 1 squared times du over 18. And then I need to figure out how to get this in terms of u instead of that variable x, which would be really difficult to do with this piece that I've got so far. It might be possible, but I don't even want to try making that expression out of this one. Like, not even going to think about it. I'm just going to try u equal to this piece, 3x squared minus 5x plus 1. Du dx is 6x. Yeah. Multiply here, 6x minus 5. Oh, 5. So dx is equal to du over 6x minus 5. So what we're going to do is factor that first part. So we want to factor out 3. Should be 6x minus 5 times u times du over 6x minus 5. So this one works out nicely once you do the right u sub, and we'll bring the 3 to the front. 6x minus 5 over 6x minus 5 reduces to 1. And integrate u du. So 3 times u squared over 2. Plus c. And don't forget to put u back into your problem. 3x squared minus 5x plus 1. That's squared, and then plus c. Let's try to do one more. I'm going to just change the power. So we're going to integrate 2x squared times x cubed minus 5 with a power of let's do 8. Okay, so you might try u equal to 2x squared, but I'm just going to go straight to letting u be x cubed minus 5. Then my derivative, du dx, would be 3x squared. And I like to solve for dx, so I'm going to multiply both sides by dx, divide both sides by 3x squared. U over 3x squared is dx. I'll take out that 2. Yeah, about 2 into different. There's x squared. I've got u to the 8th. And dx is du over 3x squared. So those x squareds are going to reduce. And I've got 2 times the integral of u to the power 8 du. And u is x cubed minus 5. Oh, we'll put that in later. We need to do the integral. So u to the 9th over 9 plus c. Two times x cubed minus 5 to the power 9. Over 9. that's good enough for now. So I plan to do practice for just practice problems that are related to or like similar but different from final exam problems. And I do want to make a little bit of homework for you from chapter 5, but it's not going to be part of your grade. Okay, thank you everyone.